Finishing up 8.3.1, we talked about in the part A, we talked about how to find the graph from the standard form of the equation, which we looked at here. And now I want to show you how to get that equation into that standard form. So there's something else you need to understand about this, about these foci that are at plus or minus C. We didn't talk about C yet. We talked about A. A is the vertices. Plus and minus A gives me the vertices of the major axis. And plus and minus B gives me the vertices of the minor axis. And C, plus and minus C, gives me the location of the foci. So if I have the focus, if I'm given the foci and one of the axes, then I can find the whole ellipse. So I want you to think about that relationship that we talked about, where these two lines, no matter where we are, these two lines that connect the foci to that point on the ellipse are, the sum of them is always equal. Like that's a string, that's a constant distance between this guy plus this guy. So that must be true here then too, where we actually get a right triangle. So our string is here and here, and we're actually making two right triangles. So this distance is C. I'll do that in purple. Actually, it's over here, right here in purple. This distance, let's do this. This distance is the C, and this distance is that length B. And if I use the Pythagorean theorem, I can find that C squared plus B squared equals A squared. And I know those letters are a little reverse of what we're used to with our hypotenuse is actually usually the C. But in this case, for the ellipses, they have the A being the hypotenuse. So that means our equation changes a little bit. So following that, the leg squared plus the other leg squared equals the hypotenuse squared. And that translates to solving for C squared. So that means I have to subtract B squared from both sides. Whoops. I get this relationship between C and A and B. And that's going to help me find the other axis. So in both cases, horizontal or vertical, I have the value of C is the distance along the major axis from the center to the focus. That's that distance right here. Or right here, depending which direction we go. And it's given by that equation that we just found. The length of the major axis is going to be 2a because it's plus and minus a. And the length of the minor axis is going to be 2b. All right, let's see if we can apply this to 17 and 19. So on your homework, you have 17 and 19. So we're going to do 18 as an example. I'm going to keep that that equation that we just made for C visible. So we found that, let me read this question here. So if I'm given the foci and the vertices, I like to kind of get a visual. So I'm going to graph what I know. So I know the vertices are at x equal to 3 and negative 3. So that means I know that axis, I don't know if it's major or minor, but then I look at the foci, and the foci I guess I'll do in green. My foci are at x equal to 1 and negative 1, and the y is 0. So that must mean that my x direction, my horizontal direction, is going to be my major axis. So my major axis is here. So that means that the A is equal to 3. This distance right here is 3. I know that's the major axis because it lies on the same line as the foci. And I also know that C equals 1 because the foci is at plus and minus 1. So I can get B using that equation above. So many choices. Okay, so B squared, actually we have C squared equals A squared minus B squared. I want to solve for B squared. I have C, so that's 1 squared. I have A, so that's 3 squared. And I want to solve for B, actually B squared. So I get 1 minus 3 squared is not minus 9. Oh, actually, let's move the B to the other side. So let's add B squared to both sides to get B squared on the left. And then I have 3 squared, or 9, minus 1, which is 8. I could also find that B is square root of 8, but really, I actually want B squared, because if I look back at the equation, my equation is, remember we said this is horizontal, so we're going to use this one. My equation actually has B squared in the denominator, so I never really need B. I need B squared. I do have to graph it, but we're not asked to graph it. But let's see. So now I can write my equation. My equation was x squared over a squared plus y squared over b squared equals 1, where a is bigger than b. And we just found that a is 3, so a squared is 9. And b is radical 8, and b squared is 8. And we have a 1 at the end. So there's my equation. So you try 17 and 19. And that wraps up 8.3.1.